Hello and welcome to this recorded session about the sum and difference of two angles of trigonometric functions. In this session, we will be summarizing the rules for finding the sum and difference of two angles and how these rules are used in solving trigonometric problems. We will be discussing the formulas for sine, cosine, and tangent of the sum and difference of two angles. And we will be exploring some examples to illustrate how these rules can be applied to solve the different types of trigonometric problems. At the end of the session, we will be answering some common questions that students often have about this topic. So make sure to stick around until the end. So whether you are a student studying trigonometry or someone who is just interested in learning more about this topic, this session will provide you with valuable insights into the sum and difference of two angles. Let's get started. Sine A plus B equals sine A cosine B plus sine B cosine A. Look, I switched sine and cosine here. I switched the angles. So here it's sine A and here it's sine B because we have two angles, A and B. And cosine, here cosine B and here cosine A. Look at the sign well. The sign here is plus, positive, sine A plus B, and the sign here is plus, sine A cosine B plus sine B cosine A. And if this sign is negative, sine A minus B, if it shows difference between these two angles. So the sign here would be negative, sine A minus B. We will write the same rule, sine A cosine B minus sine B cosine A. Cosine A plus B. Just write cosine, it change the sign. The sign here is plus, and the sign here is minus. A plus B, and here it's minus. Write cosine the first angle, cosine the second angle, minus sine the first angle, sine the second angle. And if this sign here is minus, is negative, so write here plus, just change the sign. And 10A plus B equals 10A plus 10B, write the same sign at the top, over 1 minus 10A, 10B. I changed the sign at the denominator. If this sign, is minus, so it will be 10A minus 10B over 1 plus 10A, 10B. Here in this example, we have sine angle. The angle is pi over 9, cosine pi over 18. They are two different angles. Plus cosine pi over 9, focus on cosine. I changed the angle into pi over 9, and here it's a sine pi over 18. This rule is the rule of sine A plus B because we have sine, cosine plus cosine, sine. I changed it, or I switched off these two angles. So we can write instead of that sine, pi over 9 plus pi over 18. You know pi over 9, it's a sine 180 over 9, it's 20. Okay, plus pi over 18, 180 divided by 18, pi equals 180 degrees. So it's 10, sine 30 equals half. Cotangent 2 pi minus 5 pi over 18, 2 pi is 360, and 5 pi over 18, it's a 5 multiplied by 180 divided by 18. Okay. Sorry, it's 5 pi over 12. So 5 times 180 divided by 12, it will be 75. So we'll write it as cotangent 360 minus 75. You know, 360 minus 75, this angle lies in the fourth quadrant. And in the fourth quadrant, the sign of cotangent is negative. So that is going to be negative cotangent 75. You know, negative cotangent 75, you can write it as negative 1 over tan 75. Negative 1 over tan 75. We can write this angle 75 as 45 plus 30. So that is going to be negative 1 over tan 45 plus 30. Then apply the rule of tan. So it's negative 1 over. You know, tan 45 plus 30. Here it's the sum of two angles. So we can write it as tan 45 plus tan 30 over 1 minus tan 45 tan 30. When dividing negative 1 divided by this expression here, so the denominator of the denominator will be a numerator. The rule of dividing, keep, change, flip. So that will be negative 1 as it multiplied by 1 minus tan 45 tan 30 over tan 45 plus tan 30. So multiply this negative here by all terms. So that is going to be negative 1 multiplied by 1. It's a negative 1. And negative 1 multiplied by negative tan 45 tan 30 will be positive. So write it as tan 45 tan 30 minus 1 over tan 45 plus tan 30. So tan 45, as you know, it's 1. Okay. Tan 45 is 1. And tan 30 is 1 over root 3. So 1 times 1 over root 3, it's 1 over root 3 minus 1 over tan 45 is 1. Tan 30 is 1 over root 3. Just to tidy it up and simplify it, multiply the top and the bottom by square root of 3. By square root of 3. You will end up with square root of 3 multiplied by 1 over root 3, it's 1, minus negative 1 multiplied by root 3, it's root 3 over root 3 times 1, root 3, and root 3 times 1 over root 3, it's 1. We can multiply by the conjugate. What is the conjugate of that? It's 1 minus root 3. Okay, so we can write the denominator as 1 plus root 3, 1 plus root 3, and multiply by the conjugate, which is 1 minus root 3 at the top and 1 minus root 3 at the bottom. So when multiplying 1 minus root 3 by 1 minus root 3, it will be 1 minus 2 root 3 plus 3 over 1 minus 3. 1 minus 3 equals negative 2. So we have negative 2 down here. 1 plus 3 is 4. Okay. And negative 2 root 3, write it as it. Then divide 4 divided by negative 2, it's a negative 2. And negative 2 root 3 divided by negative 2, it's root 3. So it's root 3 minus 2. Here in this example, we have cotangent B minus cotangent A equals what over sine A multiplied by sine B. So take the left-hand side and write cotangent B as 1 over tan B plus cotangent A, it's 1 over tan A. Write them as one fraction. So multiply the two denominators here by each other. Tan A times tan B. Here it's tan A, tan B. And do the scissor. Tan A multiplied by 1, it's tan A. And tan B multiplied by 1, it's tan B. And we can write instead of tan A, it's sine A over cosine A plus 10B, it's sine B over cosine B, all over divided by, here it's 10A, 10B, so write sine A over cosine A multiplied by 10B, it's sine B over cosine B. I want to cancel here cosine A, cosine B. So multiply the top and the bottom by cosine A, cosine B here, and here multiplied by cosine A, cosine B. Sine A over cosine A multiplied by, let's do it simple here, sine A over cosine A multiplied by cosine A, cosine B plus sine B over cosine B multiplied by cosine A, cosine B divided by sine A, sine B over cosine A, cosine B multiplied also by cosine A, cosine B. Then we are going to cancel cosine A, cosine B here, and cosine A, cosine B. And sine A over cosine A multiplied by cosine A, cosine B will cancel cosine A here and cosine A. And here we have cosine B down here, cosine B, and here cosine B. So one cancel another out. You are left with sine A at the top, cosine B, plus here we have sine B multiplied by cosine A over sine A, sine B. You know, here in the question we have at the denominator, we have in the denominator sine A, sine B, and here we have sine A, sine B. And if we looked at the top, it's a sine, cosine, then sine, cosine, the two angles. The two angles will switch it off. So we'll write it as sine, if you remember, sine A plus B. And if you expand it sine A plus B, you will get this expression over the denominator sine A, sine B. So right here in the missing, here we write sine A plus B. That's it. Prove that sine A plus B over sine A minus B equals 10A plus 10B over 10A minus 10B. So write the left-hand side. The left-hand side is sine A plus B over sine A minus B. Then expand the numerator, you know, sine A plus B is sine A cosine B plus sine B cosine A, as you know. And at the denominator, we have sine A minus B, which is sine A cosine B minus sine B cosine A. It's the same rule. Here we have plus, and here we have minus. Then divide the top and the bottom by cosine A, cosine B. Divide all terms of the top and all terms of the bottom by cosine A, cosine B. When dividing them, here it's cosine B and cosine B, they are going to be cancelled. And here cosine A, they have been cancelled. And cosine B, one cancel another out here. And here cosine A and cosine A, one cancel another out. We ended up with sine A over cosine A, which is 10A, plus sine B over cosine B, which is 10B, over. Here it's a sine A over cosine A. Sine A over cosine A, it's a 10A, minus sine B over cosine B, it's a 10B. Here in this example, I want to prove that cosine 52 plus cosine 68 equals sine 82. So look at these two angles. Well, it's 52 and 68. You know 52 and 68. And between them, we will get 60. You know, 60 is the mean of 52 and 68. So we can write 52 as 60 minus 8. And we can write 68 as 60 plus 8. And apply the rule of cosine. Cosine 60 minus 8. It's a cosine 60, cosine 8. And here we have minus, so change the sign and write a plus. Sine 60, sine 8. Plus cosine 60 plus 8, the same. It's cosine 60, cosine 8. The sign here is plus, so change it into minus. Minus sine 60, sine 8. Okay. We observe that we have here sine 60, sine 8, and here sine 60, sine 8, negative. So cancel. Cancel both terms. You are left with cosine 60, cosine 8, and cosine 60, cosine 8. So add them, it will be 2 cosine 60, cosine 8, and cosine 60 is half, so it's 2 times half cosine 8. Cancel 2 and half, so it's a cosine 8. This angle here, 8. We can write, instead of 8, we can write cosine 90 minus 82. Cos 90 minus 82, it's 8. And 90 minus 82, you know 90, it changes cosine into sine. So it will be sine 82. And that's the right-hand side here. I have proved that cosine 52 plus cosine 68 equals sine 82. Prove that sine 67 plus cosine 37 is equal to root 3 cosine 7. If you focused on this angle, 67, you know 67 here, we can write it as 60 plus 7. And you will find 7 here in the proof. And 37, you know 37 can be written as 30 plus 7. So just do it right instead of 67, 60 plus 7 plus cosine 37, right, to cosine 30 plus 7. Then apply the rules we have learned. Sine 60 plus 7, it's a sine 60 cosine 7 plus switch the two angles off. It will be sine 7 cosine 60 plus. Here we are going to apply the rule of cosine. So it's a cosine minus sine, because we have here plus. So it's a cosine 30 cosine 7 minus sine 30 sine 7. Sine 60, it's root 3 over 2. Cosine 7, root 3 over 2, cosine 7. And here cosine 60, it's a half. So it's a half sine 7 plus cosine 30. Here it's root 3 over 2. Right, instead of that, root 3 over 2 cosine 7 minus sine 30 sine 7. Sine 30 is half, so write half sine 7. We observe that we have two terms having two different signs, half sine 7 and negative half sine 7. Cancel them out. We ended up with root 3 over 2 cosine 7 plus root 3 over 2 cosine 7. We will add them. So it's 2 root 3 over 2 cosine 7, 2 root 3 over 2 cosine 7. Because we have root 3 over 2 cosine 7 repeated twice. Cancel 2 and 2. So it's root 3 cosine 7. And that's the right hand side. I want to get x. The question is sine x plus 30 equals to cosine x. Sine x plus 30, we can apply the rule of sine, the sum of two angles. Sine x cosine 30 plus sine 30 cosine x. That is equal to 2 cosine x. So cosine 30 is root 3 over 2. So write it as root 3 over 2 sine x plus sine 30 is half cosine x equals to cosine x. I want to cancel this 2 here, written down in the denominator. So multiply all terms of the equation by 2. So it will be root 3 sine x equals plus 1 over 2 cosine x multiplied by 2, it's cosine x, equals 2 times 2 cosine x, 4 cosine x. Move cosine x to the next side, so it's root 3 sine x equals 4 cosine x minus cosine x. 4 cosine x minus cosine x, 3 cosine x. And here we have root 3 sine x. I want to get x here, so we can get x if we divided the two sides. Here, the left-hand side is root 3 sine x equals 3 cosine x. We can divide by cosine x here and divide by cosine x here. So cosine x and cosine x have been cancelled, or we can find sine over cosine directly without dividing. We can say that sine x over cosine x, go and don't return alone, take 3 with you, it's 3 over root 3. 3 over root 3 equals what? Equals root 3. Okay. Sine over cosine, you know, it's tan x, so tan x equals root 3. What is the angle? Which tan is root 3? The angle is 60. So x equals 60. And the 10 is positive in the first and third quadrant. And the third quadrant is 180 plus the angle plus theta. Or you will add 60 plus 180, 240. Thank you for tuning into this recorded session about the sum and difference of two angles of trigonometric functions. And I hope that you found this session informative and useful in understanding the rules and formulas. And as you go forward in your studies, it's important to practice what you have learned in this session. And I encourage you to do the homework exercises related to this topic. And if you have any questions with the material covered in this session, feel free to contact me, and see you in the coming episode. Goodbye.